Hello again. We are continuing our discussion of linear inequalities by talking about how to solve them by multiplication and division. So let's look at what we talked about the last time and look at those earlier properties. There was the addition property that said that if A is bigger than B, then you can add the same amount to both sides and the inequality sign won't change. And if A is less than B, same thing. You can add the same amount, that's C, to both sides and the inequality sign won't change. Okay, subtraction, same thing. You've got three numbers. If A is greater than B, then you can subtract the same amount from both sides and the inequality sign won't change. And if A is less than B, you can subtract the same amount from both sides and the inequality sign won't change. Okay, so it doesn't matter what kind of number you add or subtract. It could be a decimal, a positive, a negative. If you're adding or subtracting the same amount to or from both sides, then that inequality sign is not going to change direction. Okay, and I bring that up because when we start talking about multiplication and division, it's not going to be the same. Okay, there's rules that we have to follow for when we're multiplying or dividing by certain numbers. So I want to talk about what happens when you multiply both sides of an inequality by the same number, and we're just going to use numbers so that you can see that the inequality sign doesn't always stay the same. So let's start with negative 2 and 4. Well, we all know that negative 2 is less than 4. So I've indicated those with the red and the blue dots on the number line. Okay, so if I multiply both sides by 3, then the negative 2 becomes a negative 6, and the 4 becomes a 12, and as you can see, the negative 6 is still lower than 12. The red dot is still lower than the blue dot. So that's still true if I multiply both sides by 3. Okay, so let's start again with our original negative 2 being less than 4. But now let's multiply both sides by negative 3 instead. Well, the negative 2 multiplied by negative 3 is going to be 6, and the 4 times negative 3 is going to be negative 12. And watch what happens. The red and the blue dots have now switched places so that the blue dot is now to the left of the red dot, which means that negative 12 is actually less than 6. So what I've written there is not true. Okay, what's actually true is that 6 is greater than negative 12, not less than. Okay, so let's try division. We're going to start with something that's true again. Negative 2 is less than 4. If I divide both sides by 2, the negative 2 is going to become a negative 1, and the 4 is going to become a 2. And as you can see, the red dot is still less than the blue dot. Negative 1 is still less than 2, so nothing's wrong here. So now we'll start again with what we had before, and this time we will divide both sides by negative 2. Well, negative 2 divided by negative 2 is 1, and 4 divided by negative 2 is negative 2. And as you can see again, the dots have switched places. The blue dot is now less than the red dot. Negative 2 is now less than 1. So what I've written just there is incorrect. What is actually true is that 1 is greater than negative 2. All right, so here's what the pattern is, and hopefully you saw it. If not, I can explain it to you. Whenever I multiplied or divided both sides of the inequality by a positive number, then that inequality sign did not change. It stayed the same, and that's easy. That's the same as it was for addition and subtraction. But whenever I multiplied or divided both sides of the inequality by a negative number, that's when the inequality sign changes. So you have to remember that when you're solving inequalities. Even though there's letters and numbers in there, that rule still follows. So here's the multiplication property for inequalities. For all A and B and positive number C, if A is bigger than B, then I can multiply both sides by the same thing and the inequality sign won't change because C is positive. And if A is less than B, same thing. I can multiply both sides by the same thing and the inequality sign won't change. Okay, now, if C is a negative number, if A is bigger than B, then if I multiply both sides by the same thing, then I have to change that inequality sign so it faces the other direction. If A is less than B, same thing. I have to multiply. If I'm multiplying both sides by the same thing, I have to change the direction of that inequality sign so that it faces the other way. Okay, division property, it's basically the same thing as it was for multiplication. I've got two things, and I'm dividing by a positive this time. The inequality sign doesn't change whether A is greater than B or A is less than B. The tricky part comes when you are dividing by a negative number. If you've got two things, then you've got to change the direction of that inequality sign when you divide both sides by the same negative number. Okay, so notice that in those steps right there. Okay, so here's some examples. So I am solving 5k is greater than or equal to 20, and I'm going to graph the solutions on a number line. Well, k is being multiplied by 5, so to undo that I need to divide both sides by 5. So what that looks like is k is less than 4. So the 5k becomes just a k, the 20 becomes just a 4. How do I graph that? Well, I look at where 4 is on the number line. I do want to include 4 because k is greater than or equal to 4. So when I've got that little extra bar underneath there, I do want to include that number, so I will use a solid dot. And since I want the numbers that are bigger than 4, I draw my arrow to the right. Okay. Now I'm solving negative 2m is less than negative 6, and I'm graphing the solutions on the number line. This time my variable m is being multiplied by negative 2, so to undo that, I divide both sides by negative 2. And remember, I'm dividing by a negative number now, so I have to change the inequality sign. So what that's going to look like is m is less than 3. Okay, so I'm going to find 3 on the number line. It looks like m is less than 3 but not equal to 3, so I have to use a hollow dot again. And since I want the numbers that are less than 3, I'm drawing my arrow to the left. Okay, here's some more examples. I'm solving d over 2 is greater than or equal to negative 1. d is being divided by 2, so to undo that I have to multiply both sides by 2. Remember, I'm multiplying by a positive number, so I don't have to do anything to the inequality sign. The d over 2 just becomes d, and the negative 1 becomes negative 2. Find the negative 2 on the number line, and since I want to include it, d is greater than or equal to negative 2. Since I want to include it, I'll use a solid dot, and I will draw the line to the right because the numbers are greater than or equal to negative 2. Now I'm solving f over negative 2 is less than 2. This time my variable f is being divided by a negative number, so to undo that, I have to multiply both sides by a negative number. And we know what that means. That means that that less than sign is going to change direction, and it's going to become a greater than sign instead. So f divided by negative 2 is just going to become f, and 2 is going to become negative 4. So I find negative 4 on the number line. It's a greater than sign, so I don't want to include the 4, so I put a hollow circle there. I want the numbers bigger than negative 4, so my arrow goes to the right. Okay, so here's a real-world example. 1/5 of the students at Pockel High School do not have smartphones. That's more than 128 students. How many students are at PHS? So 1/5 of the students, I'm letting S represent the students. So 1/5 of the students is S divided by 5, or 1/5 times S. Okay, that is more than 128 students, so that is greater than 128. And so now I need to solve. Now that I've got the situation symbolized with an inequality, I can solve it. Well, my variable is being divided by 5, so I need to multiply both sides by 5. That's not a big deal because I really don't have to change the inequality sign at all. Just multiply both sides by 5. So the S over 5 is going to be S, and the 128 is going to be 640. That means that there are more than 640 students at Pockel High School. All right, so that is solving inequalities by multiplication and division. If you have any questions, please let me know, and I will see you tomorrow.